we have to understand certain basics of limits. Now, what we have here, see for example, limit of f of x when f of x is equal to 6. Now, this is a clear determinate function. When it is a determinate function, f of x itself is 6, which means y is equal to 6. So, whatever be the value of x, the value of y is also going to be z. So, if x approaches 0 or x approaches 1 or x approaches 2 or whatever it is, the value of y will also be 6. So, the limiting value of this function is 6. So, limit of f of x as x approaches 0 itself is 6, which is f of 6, which is nothing but 6. So, the limiting value is 6. So, among these, you find that this is the right answer. So, limit of f of x as x approaches 0 is equal to 6. So, here is just a simple function which is actually a kind of what we call as a constant function, because the value of the function is always 6 immaterial of whatever be the value of x. So, in such cases, it's very easy to assess or deduce that the value of the function is 6, whatever be the value of x. If you take for the same function limit of f of x as x approaches 1, even that will 1 is also 6. Limit of f of x as x approaches 2 will also be 6. Limit of f of x as x approaches 3 will also be 6. Whatever be the value of x, the value of y is always 6. So, whatever be the corresponding, whatever value x approaches, the limit of that function is going to be 6. Right. Okay. Now here we have limit of 3x plus 2 as x approaches 2 is equal to what? First we can do it is this a determinate function? It is a very clearly determinate function. In such cases, limit as x approaches 2 is going to be f of 2 itself, which will be 3 into 2 plus 2, that is 6 plus 2, 8. So, f of 2 itself is the limit of limit of the function as x approaches 2. So, that turns out to be 8, as we did in the previous example. You just have to look at the function and observe whether it is a determinate function. If it is a determinate function, yes, the value of the function for that particular value of the variable itself is the limit. Okay, so yes, right, we have it as 8. Okay, now here we have a case. Limit of the function x squared minus 4 as upon x plus 2 as x approaches minus 2. Now, if you just imagine you do the same exercise which you did earlier, you'll end up getting minus 2 plus 2 in the denominator, whatever be the numerator, upon 0, which is totally undefined. So, what do we do? If you remind earlier, we'll take values closer and closer to minus 2, minus 1.99, minus 1.8 and find what value the function limits itself to. But that is a cumbersome process. I mean, finding out 4 to 5 values closer to minus 2 and finding out what the value of the function limits itself to. Instead of that, we can take the function. It will turn out to be x minus 2 into x plus 2 upon x plus 2. So, we just cancel this. Now, what is f of minus 2? Now, the function has become determinate. It becomes minus 2, which is minus 4. So, now in this case, once the function becomes determinate for that given particular value of x, then is nothing f of x as x approaches minus 2 is equal to f of minus 2 itself, which is nothing but minus 4. So, you get it as minus. Okay, we have it as minus 4. Okay, what do we have next? Okay, now here we have limit of the function 3 upon x squared plus 2 as x approaches infinity. Now again, you can't substitute the value of infinity over here. Definitely we don't know what infinity would be no number which is not assigned. It will be some huge trillions millions, anything. There is no end to it. So, but we know that as x approaches infinity, it will never become equal to, the denominator becomes bigger. X square becomes infinity square, much bigger. You'll find that 3 by x square, you're dividing 3 by a huge number. It will never become equal to 0, but it becomes closer and closer to 0, a value very close to 0. So we find that limit as x tends to 0, we can write it as limit of 3 by x square as x tends to infinity, and limit plus limit of 2 as x tends to infinity. Now this is a constant function, so the limit will remain 2 whatever be the value of x. Now this, as x becomes bigger and bigger and becomes closer to infinity, becomes 3 by a huge number, it limits itself to 0, the maximum value as it comes closer, or rather we can even call it as the approximate value. So that means limit of this particular function as x approaches infinity is 2. Remember one thing, whenever x approaches infinity and you have x in the denominator, the value of that particular expression will approach 0. It will not become equal to 0. The value of that function approaches 0. So we say the limit of that function is 0. Right. So among these, this is the correct option we have. Okay. Furthermore, okay, now here suppose limit of log e raised to x as x approaches 1. This is a function which you also call it as y, but now we don't have to bother about this y, we'll take f of x itself as a function. Now here this is a determinate function. Candidate should remember, if the base is not mentioned, it is taken for granted that the base is also e. So this is nothing but f of 1 itself, as that is f of the limiting value of the variable. This will be log e to the base 1. Log e raised to 1 to the base e, which is nothing but 1 log e to the base e. Now log of any number to the same base is 1 itself, so it becomes 1 into 1, which is 1. So value of this particular function when x is equal to 1 is 1. So the limit of that function as x approaches 1 is also 1. So we write it this way, limit of log e raised to x as x approaches 1 is 1 itself. So among these, this is the right option. Right, so let's check whether we got it right. Yes, we do have it right. What do we have next? Okay, now here we have the value of the limit of f of x as x approaches 3, when f of x is e raised to x squared. This is plus 2x plus 1. So the function is e raised to x squared plus 2x plus 1, and you need to find the limit of this function as x approaches 3. Now hence we need to substitute this, simplify this. This is nothing but e raised to x plus 1 the whole square. So we can just call it as L. So L is going to be e raised to x plus 1 the whole square. Now if this is a determinate function, so in that case this is going to be e raised to 3 plus 1 the whole square, which is nothing but e raised to 4 square, that is 16. So the value, the limit of this particular function, that is e raised to x square plus 2x plus 1 as x approaches 3 is nothing but e raised to 16. So since this is a determinate function, you can directly substitute the value of x as 3 and you get this thing. So it is going to be e raised to 16. Okay. All right. Now, here we have an interesting example here. Now, f of x is equal to ax square plus bx plus 6, and you have to find limit of f of x plus h minus f of x. Okay, the function is this divided by h as h approaches 0. Now when you take h approaches 0 and substitute over here, we find that suppose we do the exercise which we did in the previous example, we find that the value becomes indeterminate. That means the function is indeterminate for h being equal to 0. So here we cannot do the concept of substituting the value of h as 0. So we have to find the limiting value of this particular function. Say this function itself is say g of x. So you have to find out f of x plus h minus f of x. What is f of x plus h? F of x is this. So instead of x, wherever there is x, you put x plus h the whole square plus b into x plus h plus c. This is f of x plus h because they substituted x plus h here, x plus h here. Minus f of x. Minus f of x is ax square minus bx minus c upon h. This becomes h itself. Simplify this. This becomes a, and this is x square plus 2axh plus ah square plus bx plus bh plus c minus ax square minus bx minus c. So here you have ax square getting cancelled, c and c, bx and minus bx. The whole thing upon h. Now here again we cannot substitute, but we can take out h as a common factor. So you get 2ax plus ah plus b divided by h. Now since the h has got eliminated from the denominator, the function becomes determinate for this particular value of h. So now limit as h approaches 0 in this case is nothing but 2a. As h approaches 0, so x would remain as it is. Instead of h you put 0 plus b. So you get 2ax plus 0 plus b, that is 2ax plus b. So we are deliberately taking questions wherein the denominator could become 0. So we have factorized the numerator, simplified, factorized, cancelled away the common factor to get a final expression which is determinate for that particular value of the variable. So limit as h approaches 0 is 2ax plus b. So we get it as 2ax plus b is the value of this particular limit. Yes, and we do have it as 2ax plus b. Okay. Here we have limit of the function x plus 6 upon x plus 1 the whole raised to x plus 4, limit of this as x approaches 0. Now this is a determinate function because if we substitute x as 0, the denominator does not become 0. So it's a determinate function. So this is going to be f of 0 itself. So that will turn out to be 0 plus 6 upon 0 plus 1 upon 1 plus 4. Are we right? 1 plus 4. No, it's 0 plus 4. Made a mistake. 0 plus 4. So this will now become 6 by 1, which is 6, 6 raised to 4. So the value of this particular limit is the value of the function for x is equal to 0 because the expression is meaningful or determinate for x is equal to 0. The same thing if they ask you what will be the limit when x is equal to minus 1, then for x is equal to minus 1, the value cannot be taken as minus 1, the expression will become indeterminate. So you have to look at trying to simplifying that particular function. So in such cases, suppose after simplification, we say we are not able to factorize this. We say that limit does not exist for x as x approaches minus 1. That's what means. So that was of course an offshoot, a different example within the same example, another value for the variable. So Hence, the limit of this function as x approaches 0 is 6 raised to 4. Okay, yes, we do have it that way. Okay, now here we have a function here. The function itself is 1 upon x square plus x minus 2 minus x upon x cube minus 1, and you've been asked to find the value of this as x approaches 1. Now if you directly f of 1 you do it, it is indeterminate because the denominator becomes 0. Once the denominator becomes 0, the numerator can become 0, which is fine, but the denominator cannot become 0. So in such cases we need to simplify this. So what do? We factorize the denominator. When you factorize the denominator, you get x squared plus 2x minus x minus 2. Here we use a cube minus b cube formula. This on factorization gives you x plus 2 into x minus 1. This will turn out to be x upon x cube minus 1 cube, so which is x minus 1 into x squared plus x plus 1 using a cube minus b cube formula. Now what is the LCM of this? The LCM would have x plus 2. This x minus 1 you write it once and this 2. So the LCM is going to be x plus 2 into x minus 1 into x squared plus x plus 1. This LCM divided by this gives you x squared plus x plus 1 minus x into this divided by this denominator gives you x plus 2. So this simplifies. Okay, so let's simplify this. This turns out to be x squared plus x plus 1 minus x squared minus 2x upon x plus 2 into x minus 1 into x squared plus x plus 1. So here you have this getting cancelled and you have ultimately this will become minus x plus 1 upon x plus 2 into x minus 1 into x squared plus x plus 1. So now you can take minus common and you get x minus 1 upon x plus 2 into x minus 1 into x squared plus x plus 1. So ultimately this gets cancelled. So you get a determinate expression for this particular value of 1. Now we can substitute it. Now you find f of 1. That itself is a limit which will turn out to be 1 plus 2 into 1 squared plus 1 plus 1, which will turn out to be minus 1 upon 3 into 3, which will turn out to be minus 1 upon 9. That means in such cases, direct substitution as x is equal to 1 will make the expression indeterminate or undefined. Hence, we simplify it, cancel out the common factors to get a determinate function. And then you find out f of 1, that itself gives you as the limit. So this gives it as minus 1 by 9. So among the options given, this is our correct option. Right? Okay. Furthermore, okay. So what do we have as a function? 1 by 6, 1 by 6 square, 1 by 6 cube plus whatever it is. So here you have f of x is nothing but 1 by 6 square plus 1 by 6 cube plus 1 by 6 raised to n. Do you notice something? This is a geometric progression and it is a sum of this we need to find out. So first we convert it to a function itself. So this is geometric progression where a is 6, r is also second term by the first term or third term by the first term. A is 1 by 6. R is also 1 by 6, and hence you see that R is less than 1. So in that case, f of x is the same as s of n, which is nothing but a into 1 minus r raised to n upon 1 minus r. So let's find out. Now in that case, limit of f of x as x approaches infinity. So it is nothing but substituting. So as x approaches, here is a determinate value. So it's going to be infinity features on this. So a into a is nothing but 1 by 6 into 1 minus r raised to infinity. That is, as n approaches infinity, here n approaches infinity, it is actually n approaching infinity. So as n approaches infinity, the value of r raised to n becomes smaller and smaller. So you find that as n approaches infinity, r raised to n approaches 0 because it is 1 by 6. If it had been 6, then in that case r raised to n would also approach infinity. It is 1 by 6 raised to n, so the denominator becomes larger and larger. So r raised to n approaches 0. In that case, this itself will 1 minus 0 turns out to be 0 upon 1 minus 1 by 6. So this will now become 1 by 6 into 1 minus 0 upon 5 by 6, which will turn out to be 1 by 6 into 6 by 5, which will be nothing but 1 by 5. So candidates, please understand this part, that as n approaches infinity, r raised to n approaches 0. So that means this will ultimately can be substituted as 0. So 1 by 6 into bracket 1 minus 0 upon 5 by 6, and you get 1 by 5. So this particular function's limit is nothing but 1 by 5. Okay, let's understand. I'll explain this once more. So as, say for example, as n approach. So for example, 1 by 6 is 1 by 6. Suppose n is 1, then r, this particular value would be r raised to n would be 1 by 6. If n is equal to 2, r raised to 2 turns out to be 1 by 36, which is very small compared to 1 by 6. When n becomes 3, r cube becomes 1 upon 216, which will become 36 times smaller than this. And when n is equal to 4, r raised to 4 would be 1 upon 1296, which is still smaller, 6 times smaller than even this, 1/6 of this. So you find that as n increases from 1 to 2 to 3 to 4 to 5 to 6, you find that r raised to 4 becomes smaller and smaller and smaller and smaller. This is 1296, I'm sorry. Smaller and smaller, and gets closer and closer to 0. So whenever you have the n term in the denominator, and as n approaches infinity, the value of the entire, that particular expression will approach 0. So this is something you understand. That's how you get, suppose, as I repeat, suppose r was equal to 6. In that case, it will be r would be r raised to 1, r square is 36, r cube is 216. And you find that in this case, the value of r cube goes on increasing. It will also tend to become closer and closer to infinity. But we are dealing with 1 upon r, and hence as n approaches infinity, 1 upon r raised to n approaches 0. So hence, anyway, coming back to it, our answer is option, right option is 1 by 5. Yes, we do have that. So these are certain examples which will make you understand when you can directly to find the limit. When you can directly substitute, in this case, for example, we can't substitute x as infinity because we don't know the value of infinity. In certain other examples previously, we came across cases where if you substitute x as that particular variable, the entire function becomes indeterminate. So in these two kinds of functions, we need to use logically or sometimes factorize and cancel away common factors and then find the value of that function for that given value of the variable, and that will give us the limit.